Welcome to our challenge project video. For our project, we've had to design a product that includes embedded systems, a GUI, a database, and security measures against attackers. We've decided on creating a system that can control the lights and ventilation. Not only can you control the lights yourself, but we've also made an automatic algorithm that turns up and down the brightness based on the time of day and the sunlight levels. To make our project a reality, we've decided to use an Arduino, a tablet, and a Raspberry Pi to host all the necessary servers on. For our prototype, we've had to keep it to a tighter budget, so we emulated the tablet and Raspberry Pi in a programming language called Python. The reason for choosing Python over Java is because Python has a versatile library called Pygame, which is usually used for making 2D games. However, we've found that using this game engine for a graphical user interface was a lot easier than Java's alternative. In addition to it being easier, it also looks a whole lot better. The user can change the brightness of the lights and the speed of the ventilation using the sliders on the tablet. There is one tablet per room and one master tablet for the whole building. The master tablet is able to change the light levels and ventilation speed of every room in the building. To protect the master tablet, we've created a login screen which first identifies the user and then authenticates the user using a password we've stored in our database using an MD5 encryption. After the login screen, we've got the master home screen where you can see what rooms you've got selected. When you click the map on the top right of the master home screen, you can select different rooms to control the lights in. On the Arduino side of the project, we've used the Arduino IDE version of C++ to write a script that can receive the brightness and ventilation values from our Python app to relay them to the corresponding components. This same script sends the temperature and humidity data to the Python app. We used a lot of different sensors to measure the temperature, humidity, CO2 levels, and the amount of light in the room. We selected every sensor in such a way that it wouldn't interfere with one another. We chose a sensor called DHT11 to measure the temperature and humidity of the room. We also used a sensor called MQ135 to measure the CO2 levels in the room. This sensor uses the humidity, temperature, and air quality measurements to determine the CO2 levels. We used the light sensor to measure the amount of light in the room. This sensor uses photoconductive cells to determine the brightness in the room. When the room gets brighter, the resistance of the cell goes down. This gets used in our algorithm to determine the brightness of the lights. We also used a passive infrared sensor, PIR for short, to see if there are people in the room. The way this sensor detects whether people are in the room is through detecting big changes in infrared light levels. In this prototype, we couldn't use a DC motor since it would draw too much power from the Arduino board. So for our prototype, we've replaced the DC motor with an LED. This way we can still show that the functionality is there, but without powering off the Arduino. The main purpose of our product is to bring the energy consumption of a building way down by only using the ventilation and lights when necessary. We also hope to solve the problems with air quality control that lots of schools suffer from. By keeping a database of the measurements, we can track which room suffers from bad ventilation. Once located, it's on management to decide if fixing the issue fits the budget. The difference between our product and our competitors is our flexibility. Our product can be installed directly on top of the already pre-existing light and ventilation infrastructure, while a lot of manufacturers need their specific light or ventilation module. This was our product. While there are still many ways in which we can make our product more streamlined, we did make a working prototype that contains all of the ideas that we had when we began. This proves that our idea can be made a reality. With the right budget, enough time, and experience, we will be able to make this product for commercial use.